Hi everyone and welcome back. This is Professor Herring. In this video we're going to start Chapter 11 about intermolecular forces. In this video in particular we're going to differentiate between intra and intermolecular forces, and we're going to explore the differences between solids, liquids, and gases at the molecular level. Let's begin. So we've talked already about how structure determines the property of molecules. And we know about the structure of molecules using the Lewis structures. We can talk about the shapes of the molecules, their electron domain geometries and their molecular geometries. We can talk about the polarity of the molecules. We've also started talking about bonding information, where the electrons are within the bonds and hybrid orbitals. The next thing that we're going to address is the properties of these molecules. We're going to learn about the properties of gases, liquids, and solutions. And if and when you take Chem 112, you'll learn more extensively about the properties of solids. So this raises a question. What are the forces that exist between molecules that produce the properties that we experience? So in other words, what's happening on the molecular level that shapes our daily life? Let's take a look at liquid nitrogen. Liquid nitrogen, its molecular formula is just N2. In the solid form, you get a crystal structure, a uniform array and arrangement of the molecules, and they're lined up very nice and neatly. Once you increase the temperature high enough, you're going to cause liquid nitrogen to melt. Well, I suppose at that point it's solid nitrogen. And now we've got liquid nitrogen. And the molecules move around, they flow more freely, they're able to tumble over each other, they have higher kinetic energy. If we increase the temperature yet again, we're going to then boil our nitrogen and we'll get nitrogen gas. This is what we observe at room temperature. And there's a lot more space in between the particles. They're moving a lot more rapidly than before. And it turns out that the strength of interactions between the particles is going to affect the properties of matter. In other words, stronger interactions versus weaker interactions will lead to different types of properties, different strengths of properties. We've talked about intramolecular forces. These are the covalent or ionic bonds that hold atoms together within a molecule or a compound. We're going to now learn about intermolecular forces. And these are attractive interactions that hold distinct particles together within groups. And the difference here is that if you break an intramolecular force, the identity changes. If you break an intermolecular force, the identity does not change, but the states of matter can change. Regardless of whether we're talking about inter or intramolecular forces, breaking bonds or interactions requires energy. Whereas when we form a bond or an interaction, that releases energy. We use the kinetic molecular theory to describe what's happening at the molecular level. We know that all molecules have kinetic energy. That is, they're in constant motion in all states. And kinetic energy also is proportional to the temperature. For gases, their kinetic energy is much, much higher than their intermolecular forces. Whereas solids are the opposite. Their kinetic energy is much, much lower than the strength of their intermolecular forces. Whereas liquids are somewhere in between, and the kinetic energy that a molecule has is roughly equal to the strength of the intermolecular forces that it feels. And what we see here then is that because of the ratios of the kinetic energy and the intermolecular forces, these affect the states of matter. A phase diagram is one way to depict various states of matter and the relationships between them in respect to pressure and temperature. We'll go into a lot more depth in these later, but I wanted to point out to you that this is one way that we represent states of matter and phase changes between them. We talk about melting process, going from solid to liquid, or the freezing process, going from liquid to solid. Liquid to gas is called evaporation or boiling. Oh, excuse me. Whereas going from gas to liquid is called condensation. Finally, we can go straight from solid to gas, and that's known as sublimation. In your daily lives, you'll see this most commonly in the terms of dry ice. And then deposition is the term for going from gas to solid. So as I said earlier, from the kinetic molecular theory, we know that molecules are in constant motion. This is a depiction of what type of thing is happening on the molecular level when we look at various molecules. You can see that the molecules are moving around, and they're also within a molecule, its bonds tend to rotate or bounce around. And this molecular motion is caused by the fact that all molecules have some amount of kinetic energy. And that kinetic energy gets translated into movement, either moving the whole molecule or just moving parts of the molecule. The final video that we're going to watch here is another way to visualize the motion of particles. And this is somewhat an inception type experience where we're going to be watching myself as I narrate myself talking about this. So let's imagine that you have solid particles. Solid particles actually do move around. And this may be a surprise to you, because when you take a look at the desk that's in front of you or your laptop or whatnot, it does not appear to be moving. But in this video, I'm going to demonstrate the difference in movement that we can think about in terms of solids, liquids, and gases. So as I said, solids move around, but it's really more of a vibration. They're kind of shuffling back and forth, never really moving from their fixed positions, but they are knocking back and forth. Liquids will flow over each other, and that's because their kinetic energy is higher, about the same strength as their intermolecular forces. Whereas gases, they're bouncing all around their container with very high energy and very, very few intermolecular forces. All right, that's enough of that. Okay, so that's it for this video. Thanks for watching. If you have any questions, ask on Piazza in office hours or in recitation. Have a good day.